To prove this function is always increasing, that means they are asking you, is f dash x always smaller than 0? Is that always going downward for this domain, this definition? So our target is to calculate f prime x derivative of fx, but this format is not very convenient for us to do so. So we have to change this format to make it more favorable for our calculations. We will prefer, I need negative x. If this is negative x, I want negative 3. So that this term is negative 1 times of x plus 3. And finally can be cancelled out, become an integer. And then, but I can't change the value, so I need to think what behind to ensure we get back 6 here. So you may consider plus 3 and then plus 6, so we have plus 9 over x plus 3. So this is negative 1 plus 9 over x plus 3. Originally, x exists both in the numerator and denominator, but we just change the format, separate this, offset the same degree. We make it become x in the denominator only. And also, I get used to write in x plus 3 power negative 1, this format, so that we can get derivative of fx very easily. Negative 1 differentiate give you 0, and then another term we have 9 times, and then we have x plus 3 negative 2. The power move in the front, and then don't forget to differentiate x is give you 1 time. So negative 9 over x plus 3 squared. Don't forget our mission is this one always smaller than 0? If you can write in this format, since x is not equal to negative 3, so this square always positive. Negative divided by positive, we have enough information to claim this one always less than 0 for all x larger than negative 3. Why I have to write so is because if x is equal to negative 3, then this value is undefined, and then you predict a vertical straight line. But however, this is logically you should say is limited in this situation. And then part B, we have to get f limit x tends to infinity fx. And another advantage for this format is it separates the constant term do not affected by x and the part that affected by x. So it's much easier than both sides we have x here. So I use this format to evaluate fx. No matter what is x, this is just simply negative 1. And 9 divided by a really large number, so this becomes 0. You better show examiner you know this part becomes 0. So the limit is negative 1. In part C, basically y equal to fx is something like this. And then it's kind beyond negative 1, and also x only larger than negative 3. And then but in case you don't know how does it exactly look like, then you may just roughly draw it. It's totally nonsense, but just simply draw in this way. And then they are asking about the area bounded by this line, by y-axis, by x-axis. So we are talking about this region here. Basically you can find y-intercept, but it's not necessary. We just need to know the x-intercept so that we know our range is between 0 and until x-intercept here. So our first mission is get the x-intercept, and then the area will equal to from 0 to x1 the height. That means every height here, we add all them together. This is the area we need to find. For x-intercept, write down what you're calculating, make sure you don't get lost by yourself, and then when y is equal to 0, so that means fx equal to 0. Fx is negative 1 plus 9 over x plus 3. So we have we know the x-intercept is 6, which means that the area we need to find is from 0 to 6, when x between 0 to 6. Our height here, that means fx, time each width, very small width, tends to 0 width. Again, we are going to use this format because this format is easy, less variable, and easier to handle for derivative or integration. You may use absolute sign or just simply bracket here. It's because when x is between 0 and 6, the input is always positive. The most important questions is you have to set a strategy, and then you know what you need to gather your answer. And then in case you don't know how the graph look like, then you just simply draw the graph, and then draw any graph, and then think about how do you get the area bounded in this region.